Anybody remembers how many parameters there was in the model that was named GPT-2? GPT-2 had how many parameters? Do you remember? No. 1.2 billion. And then what happened with GPT-3? How many? No. GPT-2 had 1.5 billion. GPT-3 had 175 billion. Okay. So the other thing that, let's try now to maximize the screen and see. Oh, amazing. So the other thing that we have to is this. If I needed a motivation to incentivize you to take a look at Edge AI, this week we had one, because for a while Anthropic was out of service. And this will happen in the future. There is no way when you look at these large systems that eventually they don't fail, okay? Even if that was not the case, this week was a special week because if you remember, an entire data center from AWS was attacked, but not cyber attack as we normally say. It was physically attacked by a drone in the Middle East. Now, that prevents you from accessing cloud AI. This here, in our terminology, it's called an endpoint. An endpoint is the machine that you touch. It can be your computer or your mobile. It doesn't really matter. A lot of people still call this edge, but what I will try to give you today is a presentation about what is coming in the future that will be called Edge AI. And then you will have to talk about the cloud AI, the endpoint AI, and the edge AI. The first part of the presentation is just a reminder. The first 14 slides, I will go through them quite quickly because, as I say, it should be a reminder. The second part then is homework. The first presentation to date that gives you homework. I'm very academic. So you will have to take a look at those slides later to really fully understand because they are full of links. A reminder, everybody here knows the CAP theory, okay? So I will not even go there. Everybody probably heard that there is this new acronym that is called the PACELC because networks are rarely partitioned. It is not that common, but networks they get slow. Who has had problems? We just had a problem here, loading, you remember? Just 3 minutes ago. So the problem with networks is rarely that you need to decide between I can communicate or I cannot. It's usually, it's taking time. Loading, how much time we use in our lives loading something? Where is this thing loading? In that case, the decision to be made is a decision between lower latency and now, what? I should mute my mic. I have no sound here. Okay, it got better. And why is this important, folks? Because in the future, and not even the future, right now, although not for everyone, the endpoint computing is happening. Whoever have seen these self-driving cars, they have connections with some cloud, but they need to decide something by themselves. I have friends in all these companies. Why these things are not very popular in North Dakota? Because they cannot find the border of the street in the snow. I don't know if you know this, and I hope I'm not revealing any secret, but some of those cars stop when they see that vapor coming from the streets because they have sensors that are infrared. They think that's a human. So the reality is you cannot just count on cloud computing. You need to have the endpoint computing. And the endpoint is very powerful. In this machine here, right now, I hope I can show you. I have this I have several virtual machines in which I work, and I can run a model here inside this machine that is totally local. And I can ask it to create code and everything in my endpoint. And you can do this, and you have the link there. I have, even we are sharing, me and some colleagues, we are creating this, a framework where in 30 minutes you can get a computer to have this virtual machine and everything installed for you. Now, the problem that we have is this. As I said, the first part is just a recall. This already exists. In most companies today, you have what we call the endpoint. It goes to a proxy, and then it goes either to the cloud or intranet servers. This is things that you know. The endpoint itself, you have zero latency. But when you go internally in a network, typically you have 5 milliseconds to 20 milliseconds latency. Okay? And this is not really latency being academically correct. This is the round trip for a request. Okay? And when you go to the internet, typically the round trip takes from 20 milliseconds to 100 milliseconds. Everybody following me? Cool. Now, why we use still the data center? Because the data center will allocate to you typically 500 teraflops of power. And this here has 38 teraflops of processing power. And your intranet server, unless your intranet server is really a DAC from a container, typically has 100 teraflops. Isn't this absurd that your intranet server usually just have 3 times more than your phone nowadays? But the problem is your phone today probably has at most 1 terabyte or 2, whereas your intranet server can have hundreds of terabytes. What is that this means? This means that if I get a model, let's focus on this model here, the Gemma model. That's a model that you all can download right now to your phone and run it. You will run this thing in the intranet data center with a query of 100 tokens. And I will not have time to explain the entire tokenization issue here. But typically, this will take 10 milliseconds. For the intranet server 54, for your iPhone 142, and for your Google Pixel 180. But for the query to get to the internet server, remember, we need 100 milliseconds more. So focus on the middle column here. So the total time for each one of the calls is this one here, which means that for a query of 100 tokens, it's not that different to send the query to the server there than to run in your endpoint. So far, so good, isn't it? Cool. The problem starts to really happen when you have more tokens. And tokens are what gives your query what? What? Context, exactly. The tokens is what will give your query context. You are not just passing tokens because you will want to waste tokens from your company. You are providing context. And so here are the times when you really have 1,000 tokens or 10,000 tokens. You see the difference for the data center is not that much, but it starts to get bad for your local. Numbers are very hard to see. Let's just remember that more tokens means we need to process more in order to understand this query. And this is the visual kind of the visualization of what happens. In your data center, when you go from 100 to 1,000 to 10,000 tokens, the processing of your query doesn't really grow that much. But that's why you don't run the internet in your phone. You don't really put everything. I could put everything here, but it will not work. Okay? And I will not even go into the fact that the queries in the data center are distributed across several processors, blah, blah, blah. So the entire use of AI needs to start to really consider the use cases. You can very well run AI in your phone to find here you have all the data locally. When is my next meeting with John Doe? But you cannot do the average insurance for the contracts in your phone. You don't have this data. It will not be efficient anyway. Okay. And also, we need to start to think about resource optimization. Everybody probably had felt your phone start to get warm sometimes. And that's why we don't really run data centers out of phones. And so we need to optimize battery, we need to drop the temperature. And in the data center, there are also optimizations that need to happen. But so far, so good. That is the first part. My goal was to go through it quickly in 10 minutes and go achieved. Now I introduce you this thing called the edge. How many antennas do you think there are for cell phones all over the world? Any guesses? It's a good guess, but it is too optimistic. It is more around 10 million antennas. But that's a large number, folks. Okay, the number of data center is in the kind of 50,000. Okay, now you have 10 million antennas. These are data centers. I don't know if you know about this, but these antennas that connect us to the internet, they are powerful data centers. And until recently, there was a huge problem because these antennas were data centers that were fully closed. And because of a lot of things that I don't have time to discuss, from the fact that some manufacturers were found to be providing data connections to foreign countries, to other things that kind of relate to cost, the antennas started to get open standards. So now the antenna, this powerful antenna, started to be layered in such a way that you have just the antenna, you have the first layer of computers that transfer from the signal to the digital information, and finally you have processors. And this here is what in the future we'll call the edge. The telecom companies will let you run software here. I don't know yet the model for how this will be charged. This is exactly what is being discussed right now regarding 6G. But basically, that is where edge computing will happen in the future. So the names will probably change a little bit. So this here is the endpoint AI. This will be edge AI. And you will have the cloud AI the same way we have today. And why this is a little bit different from what we have today? Ben, I believe, was saying very correctly. Today, 5G has a lot of limitations. The 6G will at least try to remove several of those limitations. One of them is that you have 0.1 milliseconds of latency. They will change the spectrum in which the things will happen. So basically, 5G is known by the International Mobile Telecommunications Standard as what they call IMT 2020. 5G was supposed to be widespread by 2020. 6G is supposed to be widespread by 2030, which is 4 years from now. I don't believe it will be. Just like 5G is not today. I hope you, like me, go to some places where you still don't get 5G. But if you look at the specs, and in some places this is available experimentally, you see that will be a far better network. And one of the things, for example, look at connection density. This is 100,000 devices per kilometer for the square kilometer. Sometimes inside New York, you have more than 100,000 devices square kilometers. In my spare time, I run marathons. I keep telling people, do not think about texting people after a marathon. because you have 50,000 people living in this place, plus all your guests. It's impossible. So 5G will try to solve that. We have these standards coming, and there is a new concept that will happen, which is called the slice. So we all are used to this thing that is called the virtualization of CPU, virtualization of memory, but now you have the virtualization of network. You will be able to buy a slice, which is everything virtualized for you. So basically, this is a concept that comes with 6G, which is a logically isolated end-to-end virtual network that has compute, memory, bandwidth, and everything. And so basically, you will be able to go to, I don't know whom, to tell you the truth, maybe the mobile, the AT&T, and say, I want a slice because I want to run a service that will have video. I can have some latency, but after I start, I want to have bandwidth. Meanwhile, if I am someone running, I don't know, some ambulance service or drones, I want to have very little latency because if my drone doesn't know where it is, it will crash into some other place. That is the architectural change that will happen over the next few years, folks. You still have your endpoint, you have the cloud, but now you have to think about this edge native architecture. Why? Because if you don't do this, your competitor in terms of software will do. And it will provide to your customer what? A better user experience. Because in the same way that whoever is naive and thinks that today, when you go to the New York Times, your browser communicates with a server there in the New York Times or something, that doesn't happen. You probably all know what is a CDN. You have these content distribution networks that repeat the content from the New York Times all over the world so that someone browsing the New York Times from France doesn't have to send an entire packet request all over. So the edge native AI will be that edge AI that will enable this scenario that we were talking about. We will have a 0.1 millisecond latency from your endpoint to the edge, which is something you cannot really perceive. And you will have a lot of your model weights and things from your model run in the edge. So there are algorithms. I will not have time to go into detail over this, but you can start to think that this will be, I see a lot of people think, oh, the software engineers will be unemployed. Yeah, the ones that do only prompts, probably yes. But there is a lot of work to be done, folks, especially in the other layers, because except if the robots there become really alive, the network cannot connect, the AI cannot connect the cables yet. In fact, I'm so lucky that I later invite you to see this video this week. There was a demo during the Mobile World Conference in Barcelona where they demonstrated this. They demonstrated how someone pointed the phone to something and then just the computer vision happens here, sends to a model in the edge, and far less data needs to travel because you now don't need to send every pixel. You send some aggregation of the image, and then the model comes back and say, I see a person or I see a scene. Watch this demo later for you to see what is the difference between sending this to the cloud versus sending just to the edge, which is something that is happening in some contexts. I hope you all understand that in certain applications, this happens today. So what this means is that now you have to think about your applications in a different way. You have to think, my application needs a network slice that gets me from my device to the edge. Maybe that edge will communicate with a backend cloud if needed, but each slice has a network guarantee. And it will be super important that these slices are really respected. So there is an entire operating system for this edge AI that is being create, because otherwise what happens if you have a connection that is coming and you had an antenna that was from T and suddenly the new antenna is from T-Mobile, your drone stops? No, your drone needs to continue. Yeah, I know, 9 minutes. So this is why they have these AI grid requirements. They have to have this deterministic performance, and I will not go into details here. They have to be able to reclaim non-utilized resources, because if something is not using the resources and I need for a high priority task, I need to do it. And I need isolation because, again, for many reasons, from the service level agreement to cybersecurity, you don't want, as it has been happening in the past, people spying your cameras. Here are some of these scenarios where you will have edge AI applications, and I will not go through all of them, but I will focus on this one. Like, you can have federated learning or fine tuning. For example, today you probably have seen, and I worked for Google for a while, you have seen these cases in which you have a path by Google Maps and another by Waze, and the paths don't make any sense. You are there and you are, what is this? Why it's sending me there? And everybody is stuck in the same traffic jam, and you see that kind of line, a street that nobody is going through. The reason why some of those things happen nowadays, for example, is because of privacy. It is not allowed sometimes to send your data to the cloud. I had a case of a company that I know that they tried to send this personalized video from the CEO to each employee with a picture of the CEO and the employee at the end of the year. And then they realized, no, we cannot send the picture from each employee back to the United States for processing because the employees in Germany are subject to laws like this. So we will have, with this ability to just go to the edge, the ability to do some things that today we cannot do. Send the software then to Germany, and the thing happens totally within that sovereign kind of territory. And I will accelerate here and just share algorithms for this already exist. You can just later knock yourself out and read an entire paper about how this algorithm exists and so on and so forth. So, and here is what I believe it is the roadmap. I don't believe, and this is my pragmatic opinion, these things will be ready by 2030. Why? Because they are late compared to the same cycle for 5G. And so what I believe it will happen is the foundation will be there by 2030. We'll have a lot of devices that are very powerful and that will start to communicate more efficiently with the cloud. Then you will start to have, by 2030 probably, some of the telecom providers in partnership maybe with the software providers offering to you this license. Hey, you can buy, you can think of it like serverless credits. Buy these credits and run your things here. And finally, probably by 16 years from now, we will have software being more seamless, executed across the edge. And what is the call for action for you in preparation for this? Start to think about how your software can be split into at least, for example, 3 layers. One layer that is in the endpoint, one layer that is in the edge that is local to your population, and another layer that is probably in the cloud. And prioritize running what is real time in the edge, because then you will have this ability and not get into that delay of sending to the cloud data center. And be aware of resources. This will be charged. Indeed, the entire internet, I hope you all perceived that now for 2 years, nobody talks about net neutrality any longer. So we soon will totally forget about this. There will be obviously a premium internet, and an internet for the people that will not pay with more ads. And finally, the applications will have to consider privacy, because you need to consider that you cannot just start to continually capturing faces and sending to the cloud. I hope people perceived that, for example, there is a case very recently that I was flabbergasted that people were not surprised, and I understand the context. But the fact that they could retrieve those images from that person that approached the house of this famous presenter here in New York, that her mother disappeared, and after a few days, they got from the cache of the edge the images from a camera that has no memory. I hope people understand that these things are happening. So that is the thing. If it was any other scenario, that would be a privacy outrage, because it meant that someone approached a camera that has no local memory, the thing doesn't have a subscription, and the images are going somewhere. So that is something that we need to consider. I believe I used all my time, but that's it. I was in the edge. Thank you.